The location. Okay, so that is the one limitations which you are going to have in this particular tool. So when you are going to have this one, so anybody has worked in this one already, which I have sent? Is anybody has worked in that one? So just I will go through one by one once again the same program from the beginning. I will go with that one. So if you go with the structure of the assembly code, so if you go with the structure of the assembly code, so how the structure of the assembly code for your ARM instruction is going to have. So in your for your syllabus, you are going to have for what you are going to have for ARM 7 TDMI is the processor which you are going to use, or it is LPC 2148. So either it is ARM 7 TDMI or LPC 2148 is the microcontroller which you are using. So which is of make of NXP. Okay, this is a make of NXP. So this NXP is from Philips. Okay, this NXP semiconductor is from Philips. So you can use that particular thing. Okay, so now, so if you take this particular ARM 7 TDMI microcontroller, so now if you take the structure of the, if you take the structure of ARM program, if you take the structure of ARM program, so now it first it will be having the header. Okay, similarly which you are going to have in your C program. So in your C program, what you are going to have, so you are going to have, if you take in C program, so you are going to have hash include stdio.h. So like that, the ARM header, how we are going to write is, I have to define the area. I have to define the area. So just I'm going to give the name of that particular area as program 1. Okay, so I'm creating the header. So then what type of segment it is? It is a code segment. Okay, it is a type of code. This particular part of the code is going to hold the code. Okay, so that means whatever you are going to store here, so that it is going to store in your program counter, because that will be stored in some memory, and the starting address where it, from where it will going to start, so that will be stored, that the next instruction which has to be started, that will be loaded in the program counter. So next will be read only. So that means this particular part of the code is only read only. So next, once I have this one, I'm going to have the main. Okay, so your main is nothing but the entry part of your code. So you're going to have the entry. So next, you're going to have your open brace. So if you are going to have the open brace, you are going to start. Your start is nothing but the label. So this is nothing but the label. So the label which you are going to have, this will be have some address. The label which you are going to have, this will be have some address from where the program, actual program starts. So this one will be opening brace in the SVP program. This will be our start. Now, once it is done, so you are going to, at the end, you are going to close the brace. So similarly, you are going to entry here, and if you want to terminate, you can terminate at the end. So this is the basic structure. So you can have n number of instructions here. Okay, you can have the instruction 1, instruction 2, perform some operation. You require some of the instructions, right? So similarly, if you want to perform the action, you are going to have the here also, you are going to have the instruction 1, instruction 2, instruction 3, you are going to have. Okay, so that's what the limitations which you are going to have. So why I'm going with by the side by side of your C program as well as the assembly code is, so first you start writing the code by yourself. So it is, you should know how to write the program. So if you know how to write the program and you come to know that, it will become easy for you to write the program. So this particular structure is common for all. So only thing is the program may be changing. This particular program 1, program 2, that will be changing. That's it, depending upon the type of the program which you are executing. So if you are executing program 1, it will be program 1. So if you want to write a code for the different one, it will be program 2. So if you are writing for the other program, it will be program 3. Okay, that's what it is going to have. So now let's coming to the first program. So if you take the area, so what do you mean by area? So area is nothing but it's basically used to start a new code or data section. Okay. So if you take, this is nothing but one typical structure of your ARM code. So now, so when you are writing your code, so you are going to have the area, some of the derivatives. So we should have to have some of the assembler derivatives. So this I have told already. Just I am once again repeating since it is your lab class. So it's exclusively kept for the lab class. Once again I am going to read or tell all these things about you. So you are going to have the area derivative. So this is area is nothing but the derivative. So what is this particular area derivative? It is basically used. It's basically used to start a new code. It's basically used to start a new code. Start new code. New code segment. Okay. Or it may be a data segment also. Or it may be a data segment also. Or it may be either it can start with the code segment or it can start with the data segment. So now inside that one, you are going to have the code, right? Inside that particular structure, you are going to have the code. So now this particular section, what it contains is, this particular section contains the instructions. It contains instructions. Okay. So whenever you are going to have the instructions, all the instructions which you are going to have, it will be only read only and is only read only. The instructions which you are going to have is only read only. So next is, you are going to, in some of the code, we are going to make use of the data. This is one of the derivative which you are going to have, assembler directive. So this particular section contains data. Your section data, this particular section contains data. So whenever the data is there, it is not only read only. So data, and it is a read write. Okay, so it is a read write fashion. So it's a read write fashion. Okay, which you are going to have. Now you had read only. So the read only specifies that it is only read the contents. So this part of the section from where you are going to write it, the part of the section is only read only. The part of the section is only read only. Similarly, read write is there. So if you take the read write option, so if you take the read write is another assembly directory which you are going to have. Okay. So in the read write option, what it is going to do is, this particular section is only, this section is read write. That means whatever the variables you are going to define within this particular section, either it can be read or it can be written. Okay, the part of the section which you are going to have here in this section is either you can read it or you can write it. So now in your code we have defined, in your microcontroller we have defined the code, two types of instruction set. What are the two types of instruction sets we have defined? That is, one is your thumb instruction set and other is your ARM instruction set. So what is the size of the thumb instruction set? Or what is the size of the thumb instruction set? Can anyone tell? What's the size? If you take the thumb instruction set, so two types of instruction set you are going to have. Two type of instruction set which you are going to write. By default, it will be which instruction set by default? So one will be thumb instruction set, other will be ARM instruction set. These are the two instruction set which you are going to have. Now when you are going to have two types of instruction set, you can see it here. Your thumb, if you take thumb instruction set, it is 16-bit. So this is 16-bit. If you take the ARM instruction set, it is 32-bit instruction set. Now, when you are writing the code, even the code, it has to define that which code has to be written in thumb instruction set. When I should understand whatever the instruction I am executing, that is part of the thumb instruction set. And if you want to say that what of the when you are executing the instruction, the type of the instruction I am executing, whether it's a it's based on ARM instruction set. So to have that particular bifurcation, we are going to have the other another assembler directive, which is known as code 16 and code 32. So code 32, it is going to tell the assembler, it is going to tell the assembler to follow 16-bit thumb instruction set. So it's going to tell you that it's going to follow 16-bit thumb instruction set. Whereas similarly, we are going to have code 32. So code 32 is there. It is going to basically indicate 32-bit ARM instruction set. It is going to tell 32-bit ARM instruction set. So these are the two things which you have to keep in your mind. One is code 16, which is assembler to follow 16-bit thumb instruction set. And you are going to have the code 32, which will indicate you that it is going to follow the 32-bit instruction set. Now, we can define some of the variables. Okay, we can define the variables or variables. So variables is nothing but what? Named memory location. Variable is nothing but named memory location. Now, whatever the variable you can define, so define the variable can be either here, it can be a 8-bit, it can be a 16-bit, it can be a 32-bit. Now, if I am defining any variable as 8-bit, I have to define it as DCB. That is, DCB stands for define constant byte. Okay, DCB stands for define constant byte. Okay, so now similarly, yeah, tell me. Yeah.
Repeat variable one, sir.
Variable is nothing but the named memory location. Okay. So if you take the variable, as the definition for your variable remains same for all the programming languages. Either it may be assembly or it may be any higher level languages. Okay. So if you take the variable, here the variable is nothing but what? Named memory location. Okay. So now, but in your higher level language, what will happen? Whenever you are defining the variable, the size of the variable depends upon the type of the compiler or type of the system which you are going to use. Now, if you take, for example, if you are taking the C program, if you are running the C program in your Linux, and if you are running the same program using your DOS. So if you take the DOS operating system, so you are going to have the Turbo C compiler. So maybe some of you have used that particular compiler. So if you take the Turbo C compiler, the compiler which you are going to use is a 16-bit compiler. Okay. So there, the size of the int will be 2 bytes. Whereas in your Linux, if you take, or in your Microsoft Visual Studio, if you come, so the size of the compiler which you are going to have is 32-bit compiler. It is GCC compiler. Okay. So there is two difference between the compilers which you are going to use. That is, what is the size of the int in your Turbo C compiler and what is the size of the int in your GCC compiler. If you take the size of the integer in Turbo C compiler, the size of the int will be 2 bytes. Okay. So if it's the same size of the byte in your GCC Turbo C compiler is 2 bytes for integer. Okay. So whereas in your GCC compiler, the size of the int is 4 bytes. So this will vary depending upon the data type which you are going to use. So if you take the data types, there are primitive data types and derived data types. If you take the higher level language. Now, whatever the size it is going to change, that will be changing only depending upon the primitive data types. That will be changing only upon the primitive data types. Okay. So here in your variable, when you want to define with respect to your assembly code, that is ARM code. If I want to define with respect to 8-bit, then it is defined as DCB. That is defined constant byte. Okay. So now if I want to have the 16-bit, so 16-bit is referred as word. So that will be defined as defined constant word. Okay. So now here also, if I want to define 32-bit, it is DCD. DCD stands for defined constant word. So if you take DCW, It will define constant word. Okay. So next, if you take the DCD, so it is design constant double word. Now, if you want to work with 8-bit, I can use the type of the variable as DCB. If I want to work with 16-bit, I can use the type of the variable as DCW. If I want to work with 32-bit, I can have the variable defined as double word. Okay. So anybody having any doubt till here now? Anybody having any doubt?
DCB.
Define constant double word.
Okay.
DCD. Define constant double word. If you are taking the word is a 16-bit data. Whereas if you take the double word will be 32-bit data. Any doubt? Anybody having any doubt?
No,
Okay.
sir.
So now next, when it comes to the, similarly, you can have the other variables also, like DCQ is there. So it refers define constant quad word. Define constant quad word. So quad word means how much, what is the size of your quad word now? What will be the size? Can anyone tell?
60.
Which one? How much? It will be 64-bit. Okay.
4.
So if you had quad word, that means word is 16, quad is 4. So totally it will be 64-bit. Size of the each individual number here. What's the size?
8.
Yeah, here it is 8-bit. Now, the same thing I am explaining, that's it, nothing else. So if I take the memory location, for example, I'm starting from 1000, 1001, 1002, 1003, 1004, 1005, 1006, 1007 is the memory location what I'm going to have to store this particular data. Okay. So now if I'm going with DCB, for example, okay, if I'm going with DCB, so what data will be stored in 10?
Hexadecimal value.
Hexadecimal value of 10. Okay, so 10 it will be stored. For 20 it will be storing what? It is 20, it is going to store 14. For 30 it will be storing what? 16 ones are 16, it will be 1 E. For 40 it is going to store 2 8. Now, as I told you from the basics, when you are defining the bytes, one memory location is going to store how many bytes of data? One memory location is going to store 1 byte of data.
1 bit.
Okay, one memory location is going to store 1 byte of data. That you make a note. So make a note wherever you want. So it is nothing but what? One memory location can hold 1 byte of data. One memory location code can hold 1 byte of data. That's what it is going to have. So that you make a note. Now, the same thing, if I'm defining var1 as DCW, that is 10, I'm going to have 20, 30, 40. For example, I'm telling, if I'm going with DCW, how the data will be stored now? Can you anyone tell now? Now it is, what is each
16.
number? Yeah, what is each number is consuming now? The each number is consuming how many bits? 16-bit. Each number is consuming 16-bit. Now, to consume 16-bit, how many memory location to store 16-bit of data? How many memory location you require?
2 bits.
Yeah,
2 bytes.
two memory locations you require, right? To store 2 bytes of data, 16-bit, you require 2 memory location. Now, here the same number 10. If I'm going with a 10, it will be how it will be represented. It will be 0010, right? If I'm going with this one, binary values. Now first it will be 0 0 1 0. It is going to store like this. So no, not 0 0. This is 1 0 0 0. So that is lower byte will be in the lower address, higher byte will be in the higher address. Okay. Though this is lower byte. Lower byte will be stored in the lower address. Higher byte will be stored in the higher address. So now, can you tell what is the data it is going to store here? So here 20, if you tell, so 20, if I am representing in the 16 bit, then
Sir,
it will.
repeat, sir.
Which one? This part?
DCW, sir.
Okay. So DCW, if you take, for example, okay, in DCW, what will happen? It is the data is going to consume 16 bit. It is going to consume 16 bit. Now, what you have to store in this particular, now if it is consuming 16 bit, I have to represent that one in 16 bit. So if I take this one, it is 1010 followed by 0000 0000 0000. If I am representing in binary, that is 16 bit. Okay. Now if I am taking this one as 0 0 0, it is A. Instead of 10, it will be A. Right? Any doubt? Anybody having any doubt? Now, yeah? Anybody having any doubt? No, right? Now, what it is going to store is, here you can see it here. Now, can you tell what will be stored in your higher memory or lower memory address? What it will be stored in these two? Lower byte is going to be stored in lower address. Lower byte is stored in lower address. So now where the data will be stored? 0A in your 1000. So here also 0A only. For example, it is converted into hexadecimal, it will be 0A itself. So now in the next value, what it is going to store? 0 0. Anybody having any doubt now? Anybody having any doubt? Anybody having any doubt?
Yes, sir.
Okay, so just reply. Now,
For each value, we have to take 16 bits, sir.
which one? Yeah, because it is DCW, right? If it is W, it is how many bits it is going to consume each number? It is going to consume 16 bit, right?
Hmm.
So if it is 16 bit, if I have to store 16 bit of data, how many memory location I require?
2 bytes.
Yeah, 2 memory location you require, because one memory location is can store only 1 byte of data. One memory location can store only 1 byte of data. Any doubt? So since I have to store 16 bit data, if I want to store 16 bit data, how many memory location you require? 2 memory location is required. If I define it as DCW. Okay. So now the next number is what? 20. So what is the value you are going to get for 20? It is 0 0 1
1 4.
1 4. Now, what will be storing in 1002? What value will be stored in 1002?
1 4.
What value will be stored in 1003?
0 0.
0
0
0.
0.
Okay. Similarly for 30 now. If I take for 30, if I convert to hexadecimal, what is the hexadecimal value you are going to get? 1
1 E.
1E.
1
So, but it will be 001E because it is a how many bytes of data? 16 bit of data. That is 2 bytes. So now in this address, it will go 1E. 1005, it will go 00. Similarly, if I'm going with 40, if I'm going with 40, what is the binary hexadecimal equivalent 40? It will be 2 8, followed by how much? It will be 00. So here it will go 2 8. Here it is 00. Anybody having any doubt now?
No, sir.
Now you can see the difference when you define it as define constant byte. How many memory location was required to store the same number? How many memory location was required?
1 byte.
No, totally how many memory location? Here it is 4 values are there. So you are going to have 4.
4.
If the same numbers, if I'm defining it as word, how many memory location it is taking?
8.
8.
Understood? Anybody having any doubt? Now, similarly, if I'm going with DCD, okay, so the same number I'm about to go. So if I want to go with DCD, for example, so if I go with DCD, so DCD, now how the number 10 will be represented now? If I'm going to have 10, if I'm going to have the DCD, so DCD stands for what? Define constant, double word. So what is the size it is going to take? It is 32 bit.
32-bit.
Okay. So now if I want to store this particular bit, 32 bit, it is 8 bit, 0A. Next it will be 00, 00, 00. Anybody having any doubt? Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay, now to store this particular number, how many memory location you require?
4 bytes.
4 memory location you require, right? You require 4 memory location. Now when you have starting from the same, if I'm defining with define constant double word, what will be stored in this particular memory location 1000? As I told you that,
0A.
0.
yeah. What will be the 1001?
0, 0.
0? Yeah, tell
Zero.
me.
0.
0. Next 1002?
0, 0.
0, 0.
Again 1003? 0, 0.
0, 0.
0.
Next number is what? 20, 30, 40. Now, if I convert this to 20, what you are going to have? 1E 00 00 00 00. Okay. So now what will be stored in this particular address 1004? It will be 1E
1.
00 00 00. Anybody having any doubt? So now if I want to have 30, it will be what? So no, it is 14, right? So this will be 14. So for 30, it will be 1E. Okay, 1E 00 00 00.
Sir, for 20, it is 1 4, sir.
Yeah, 14 only. I changed it that one. Okay. Okay, 14. Okay. So it is 14. So similarly for 30, it will be 1E. So it will be 1E 00 00 00. Similarly for 42, it will be what? 28 00 00
8.
00. So it will be 28 followed by 00 00 00. So how many memory location you require? If you define the variable as DCD now, to store the same 4 numbers?
16.
16.
Yeah, 16. So that is where, why I am telling this one is, that is where the optimization comes into the picture. Where you because when you come to the optimization can be done in 2 ways. Either when you talk with the ADA. So what are the 2 types of complexity you have? You have studied, right, in your design of algorithms. What are the complexities level? One is space complexity, other is time complexity. Okay. Now, in the space complexity, what will happen? What I need to reduce with respect to the code? I have to reduce the size of the code. Now, when you are, this is where your optimization comes into the picture. In which part of the code you use only byte data. So if you are going with the byte data, it is going to reduce the consumption of the code. Because if you go with the DCB and DCW, how much space you have been reduced now? The same number I am storing. If I'm going with DCD and DCW, how many memory location you have reduced? How many memory location you have reduced? If I'm going with DCW and DCD, how many memory location you are getting in DCB to store the same numbers? 4 numbers?
4 memory location.
Yeah. Here in DCW, how many memory location?
8.
Yeah.
Eight.
In your DCD, it is 16. Now,
16.
yeah, if I'm using DCW, if I'm going to have only 8-bit of data, so as a programmer, I should know that what is the maximum size of data I'm going to use that for particular application. When you are going with that one, so if I'm going to use DCD, then it is going to consume more space. If you take, instead of going for DCB, if I'm going with DCD, it is going to consume more space. Now, what is the how much memory location you are reduced here? If I'm going with DCW, it is 16 minus 4, which is 12 memory location.
8.
16 minus 4, it is 12, right? Okay.
Yes, sir.
Now, if you are reducing 12 memory location, how many bytes of data you have reduced?
3 bytes.
12.
12 bytes. So it is going to reduce the size of the code by how many bytes? 12 bytes. Okay. Any doubt? Anybody having any doubt? Because these are the basics. You should know how to use the program, how to use it when you are doing the optimization of the code. Because the optimization is very, very, very important when you are writing the code, efficient code. Okay. So now once you have come this one, so next
What optimization, sir?
optimization is nothing but what? So optimization, why you are going to do? So when you are going with optimization, they are going to have space optimization as well as the running time optimization. If I want to speed up my code, so if I want to speed up my code, what type of data type I have to use? Now, for example, as I told you that I have to make use of DCB and DCD, the same number. So for same 4 numbers, it was consuming 4 memory location. This was consuming 16 memory location. Now, when you want to add the memory data into that one, you should have some time to fill that particular memory, right? It is like the class. If you are in the class, storing one bench is taking less time, or keeping the 4 benches are taking more, less time. So now that is like that. That's analogy is like that. So now when the memory location is there, if I want to fill, I have 10 numbers. If I'm defining it as DCB, then it is going to store only one number, 1 byte of data into the memory location. But if I'm defining that one as a double word, then I have to fill how many memory location? How many memory location I have to fill? 4. Now filling the 4 memory location is faster, or filling the 1 memory location is faster? Which one is faster? Filling 1 memory location is faster, or filling 4 memory location is faster?
1 memory location.
Yeah, filling 1 memory location is faster. Now that is what optimization tells all about. Optimization is what? Whenever the requirement, because as a developer, you will be knowing what is your requirement is, right? Who is knowing the requirement? The designer and the developer is going to know the requirement. So now he has to optimize the code where I can improve the performance, where I can reduce the space of my code, how to reduce the space, that the developer should know. Okay, that is the work of the developer, where I should optimize my code. That is what called the optimization. When it comes to the optimization, so where I have to reduce the space, where I have to increase the performance, that matters a lot. Okay, so that is what the optimization is all about. Optimize means what? With the minimum functionality, I have to increase the performance. That's what optimization is all about. Okay. Anybody having any doubt? Anybody having any doubt?
No, sir.
Okay. So now these are some of the basics which you require for your program lab part. Now when it comes to the lab part, so what are the number of registers you are going to have in your ARM? If you take the registers, you are going to have the general purpose register from R0 to R15.
R15.
So you are going to use R0 to R12 for general purpose. Okay, GPRs, they are going to call it by. Next is R13, R14, or R15. These are used for special purpose or only for some fixed purpose. R15 is for what?
Stack
Program
pointer.
counter.
Yeah, R15 is program counter. R14 is
Link
Link
register.
register.
link register. Your R13 is
Stack.
Stack pointer.
stack pointer. Okay. So now these three registers are exclusively used for special purpose. Your R13 is used for stack pointer. R14 is used for link register. R15 is used for program counter. So what is the purpose of the program counter? What is the purpose of the program counter? What the program counter holds?
The next execution.
Yeah, the program counter holds the address of next instruction to be executed. It holds the address of next instruction to be executed. What the link register holds? What the link register holds? Anybody forgotten or what?
It's just the address which is already being executed.
No, it holds the return address of the program. Return address it is going to hold. So as I told you that return address, still you have not understood the part of the return address, I think. So for example, I'm going to execute the main program. I'm explaining in terms of C program. Okay. I'm going to have some variable initialized. I'm not initialized like A, B, C, D. For example, I'm telling. Okay. So now I want to add these two numbers. Okay. So I'm going to initialize some numbers to A is equal to B is equal to 10. So next C is equal to, I'm going to write the function to calculate the sum. I'm going to write the function to calculate the sum. Next, after that one, I'm going to print. After that one, I am going to perform some operation. Some operation I'm going to perform. X operation I'm going to do. So this is where the program ends. Now, whenever you are doing this one, this will be stored in some address. Because your variable means what? The variable has to be stored in some memory location and some operation has to be performed. So it is going to have some instruction. Some address will be there. This particular instruction will be this particular statement will be have some address. This particular instruction will be having some address. This particular instruction will be having some address. Understood? Now, when you make a function call, where the flow has to go? The flow will call to the function call. Okay, int A, int B. So it will be local to here. So now I'm going to return A plus B. That is what the sum of two numbers. So now when it is returning here, it will come here and it will assign the value for sum and AB. Which instruction has to be executed next now? Which instruction has to be executed next? In your main program, after this particular instruction, which instruction has to be executed? Which statement has to get executed, for example? This is the statement. This after this statement, this printf statement has to be executed. Right or wrong? Your printf has to be executed, right?
Once again, sir.
Yeah.
Once again, you repeat that, sir.
Say, I have some statements running in my program, C program, right? Statement 1 will be running, statement 2 is running, statement 3 is running, statement 4 is running. Now, all these statements will be stored in some address. Stored in some address. So that will be generated by your compiler, to which address it has to store. Any doubt? Any doubt?
No, sir.
Now, this statement will be executed. Now, this particular, when this executing this particular statement, assume that I am executing in this particular address, that particular statement, because that is also an instruction, which is creating a memory location of type int. So now, when it is assigning, I am assigning the data, some instruction it will be running. It has to perform this particular operation of initialization. So this also will run, it will be running in some address. Assume that, right? Your statement 2 is running in 1004 address and your statement 3 is running in 1008 address. Now, but where the sum is running exactly, assume that sum is running in 2004 address. Sum is a function which is written outside the main, right or wrong? Right or wrong?
Yes, sir.
Yeah, when it is written outside the main, it is located in different memory location. It is not being a sequential order. Now, for this particular main function, the sequence is what? 1000, 1004, 1008, 1008. Right? Now, when this particular statement execute, what the program counter has to load with? The program counter, what it holds? It holds the next instruction to be executed. Your program counter holds the next instruction to be executed. Whenever the function calls, which address it has to load here according to this particular program? Which address it has to load? It is calling the sum function, right? If it is calling the sum function, where the sum function address is located? It is located in address 2004, because that is where it has to start executing. So now, initially what will be there? Initially the program counter will be having 1004, because once this particular instruction starts, it will load the next instruction to be executed. The next instruction which is executing is 1000A initially. Initially, it will be 1000A. Now, once the program function call happens, the program counter value has to be replaced with what? It has to discard 1000A. It has to replace with 1000, 2004. Now, I want next is after the completion of this particular function, which instruction has to be executed? Which statement has to be executed?
Printf.
Yeah, printer. That is in which address? That is in
1008.
1000A address. Now I have to keep track of that particular address also, right? Because if I want to execute that particular statement, I want the address where that particular instruction is located. Right or wrong? Right or wrong?
Yes, sir.
Yeah. Now,
Yes, sir.
this address to where it has to return after execution of this particular function, the address where it has to return, this particular return address will be stored in linked register. You understood now what it was? You understood or not?
Yes.
Understood.
Yeah. This is where it is going to have always the return address linked register. It is holding the return address. Return address when it comes is when you are writing a program with the functions. So here in the high level language, we are calling it by functions. Whether in a low level language, we are calling it by subroutines. In the high level language, we are calling it by functions. In your low level language, when it comes, we are calling the same functions as the subroutines. Is it? It is going to splitting the problem and writing the problem in a different part. That's it. So your stack pointer is going to hold the stack contains where the present stack pointer is located. That you know, I think. Now, when it comes to the program, the first program which you are going to have, after having all the basics, just go through the basics now. All these basics what I have taught today, because that is very, very important for your further programming. So next you are going to have the entry directive. You are going to have the entry directive. So now your entry directive is similar to the as defined in C. So it is similar to as defined in C. Okay. So it is symbol. It is symbol. Okay. So it will be symbol with value defined by expression. So it is no, it is no. Sorry, this is not the thing. Okay. I just if you take the entry, so it is nothing but the program entry point. So it is nothing but the program entry point to the linker. So it is nothing but the program entry point to the linker. Okay. So there are another derivative called EQ. So where it is equivalent to hash define. It is equivalent to hash define. Okay. So you have gone through hash define printf p. Can you have the statement like this in your C program? because you have to go through the C program in your assembly, because your part B is full of C program only. Your hardware part, when it comes, is full of C program itself. So you should know what is the hash derivative, okay, hash defined derivative. So this is nothing but what? These are nothing but the macros. So this is printf p. Wherever the printf is there, wherever the p will be there, wherever the printf comes, it will be replaced with p. That's what it's telling. So if you are going to have hash defined p with printf, that means I can replace p wherever p comes, printf. So you can check it here. So if you take the main program, so now I have hash define p printf. So p allow her. So can you, this will be a valid statement? Can anyone has tried this particular part like this? Hash define part, hash define p with printf. Okay. So now what your compiler will do is at the runtime, wherever the p it encounters before execution, it is going to replace with printf. So what it tells, it's a valid statement. So you can try it in your home if you have the C program. So use it wherever the p with printf. So I am reducing the burden if I want to reduce. So only problem which you are going to have is it is going to increase the time to run the program. That's it, nothing else. But there are some optimization has to be done. You want to replace some of the part of the code with the multiple versions. Okay. So anybody having any doubt till now?
Sir, only P or any other different alphabet, sir?
Any different. You can use A also. You can use your name also. That is left to you. It is not exclusive as P. Either it can be A or it can be B. Either it can be any name. Anything you can use. That is left to you. But only thing is when it is running, but whatever you are going to define here, that should be what you have specified here in the beginning. So if you are defining hash define, so like for example, Suresh with printf, I'm going to tell. So it is going to give you that main. So I'm going to have Suresh within syntax allow word. It will work fine. Okay, this whatever is wherever the Suresh it encounters, it is just replacing that particular part with what? Printf. It may be not only my name, it may be any alphabet. A, B, C, D, that is left to you. How we are going to use it. Okay. So just go through these things. These are the basics which you require for your assembly code. So I think I'm telling from the beginning, you just go through the C programming perfectly. So people have not taken that much serious, I think. So now also it is having a time where you need to concentrate more on your C program. So C is vast. So when it comes to the hardware part, when you come to the embedded system, I think 80%, 80 to 90% of the embedded systems software will be written in C program only. So that's why I'm telling you become perfect in C. So why if you become perfect in C, so then learning other languages is not that much difficult. So hardly it may take 15 days to 1 month. That's it, nothing else. You will not come to know. So you become perfect in C. That's it. This is my sincere suggestion from my side. Okay. So once you have done, so your first program is there, right? So which one is your first program? So we are going to have, you can see that here, write a program to multiply two 16-bit numbers. So here they are going to tell that write a program to multiply two 16-bit numbers. Okay. Now, so two numbers I have to define, right? So if I am writing in a C program, so I am going to define using what? If I am writing that one in C program, hash include stdio data. This is a file which I am using for my printfs and scanfs to work. That's it, nothing else. So now main is there, int AB is there, but I am not creating any memory location. This is not there in assembly. I'm directly loading the value into the registers. For that particular reason, int A is equal to 10, B is equal to 20. I'm going to multiply. So I'm going to have some variable C, and I'm going to have 10 star 20. That is A star B. What I am going to perform in C program. Okay. But I'm not storing any data in memory. So that particular DCD part and DCB part will not come there now. So if I'm going to execute this same program in assembly, first I have to define area. Area, what is the name of the program? Multiply. The part of the program which you are going to have is code, and then it will be read only.
Read only.
Now I have the entry point here. Okay, entry point. So I'm going to start the program. This particular part is nothing but the label. Label is nothing but what? It's one address from where the execution of the program starts. So label is nothing but what? Is one address. It will be having one address. So that particular address from where your program starts. Okay. So next you're going to write, I'm going to move some numbers directly. Move #10. 1 minute. So I'm going to move some data into some register. 10 I'm moving to one register. I want another data. I am moving it to other register. So now I need to multiply these two data. So the limitations in this particular program is what? I have to limit this particular value to how many bits? 16 bit. So what's the maximum value it can store if it has 16 bit? What's the maximum value? If it is 16 bit, what is the maximum value you can store?
2 bits.
16 bit means what? 2 bytes, right? Now number in decimal number I am asking. What the maximum number I can store? Here I am storing 10. So the 10 what you are going to store is either it will be 0, 0, 0, 0, 0, 0, 0, like that 0, 0, 0, 1, 0, 1, 0, right? Get it out? This is 16 bit. What I am going to store? What is the maximum value you can store? It will be 2 power 16. What is 2 power 16? What's the value we are going to have? 2 power 16. I think you have not gone through your C programming properly in your base. That's the problem why you are not able to answer these questions. So what is the value of 2 power 16? Can you calculate it? You have the system right in your home, or calculator you have, right? What is 2 power 16?
536.
Yeah?
65,000 to 536.
So now it can store the value from 65,000, 65 to 535. Okay, these are the numbers it can store. Up to this number I can enter into the register or not. So this is the maximum value which you can get from 16 bit. Okay. So that's how the number representation comes when it comes to the microprocessor. Okay. So that is where you should know all these things. So next, once these two are over, so what I have to do next, I need to multiply. So I'm going to multiply. I'm going to store in the result R3. What contents I need to multiply? R1 and R0. So I'm multiplying the contents of R0 and R1, and the result which you are going to get, that will be stored in R3. So what this operation will do? R3 is equal to R1 star R0. Any doubt?
Sir, screen lag ಆಗ್ತಿದೆ.
Lag ಆಗ್ತಿದೆಯಾ? No, I don't know.
Yes, sir.
It's displaying now.
So only maximum value is displayed. That explanation is not displayed.
Okay. Okay. Whether now it's displaying properly?
No, sir.
No. I will close the screen. I will open 1 minute. So whether it's displaying now properly, it's synchronizing properly. Maximum value.
Yes, sir.
Okay. So now here, so the maximum value is 216. The maximum value which can store is 0 to 65,535. Okay. So since after entering the data into the register R0, that is 10 I am moved to R0, 20 I am moved to R1. So now here I'm going to multiply the data of contents of R0 with R1 and I'm going to store the result in R3. So your R3 will become destination operand. Your R1 is a source operand 1 and R0 is a source operand 2. Okay. Once it is multiplied, the result will be stored in R3 and you are going to end the program. So this is how the program will be written. This is your first program, which is simple. It is going to multiply to 16-bit number. So that means what is the maximum number you can give it here? What is the maximum number you can give? At the place of 10, what is the maximum value you can give? The maximum value you can give is 65,535. The maximum value which can,
65,535.
yeah, that is the maximum value you can give. Apart from above 65,535, even the register can hold the data you are not supposed to give. Okay, you have to give only 65,535 as the program statement indicates that you have to multiply the two 16-bit numbers. Okay, so now, but the size of the register is how much? If you take the size of the register, what is the size of the register? If you take the R0, what is the size of the register in your ARM? Size of the register. How many bits?
32-bit.
Yeah, 32-bit, right? So the size of the bit is 32. Now if it is 32-bit, what is the maximum number the register can hold?
2 power 32.
Yeah, 2 power 32 is the maximum number which it can hold. So now we are coming to the basics properly. So this is what you require to understand basically how the internal representation of microprocessor is going to go. So this is very, very important when it comes to the microprocessor. Okay. So this you should know. So once you have this one, so once you are writing the program, so you just run that particular program. So now when you are going to have multiplication of two 16-bit number, multiplication of two 16-bit number, result will be how many bits you are going to get maximum. If you are multiplying two 16-bit number, the result is going to be how many bits? Have you gone with the multiplication in your CO? Huh? How many bits? Multiplication, yeah, 32-bit. The result what you are going to get, it will be a 32-bit. Okay, the result what you are going to get is 32-bit. So that's why if you are multiplying two 16-bit numbers, it is going to store result in 32-bit. Since the maximum result, the maximum size of the register which you have in your ARM processor is 32-bit. So that is the reason why it is going to do, you are going to do only the two 16-bit number, multiplication of two 16-bit number. Okay. So any doubt? Anybody having any doubt now, till now? Now you have, okay, you have the worksim. So this particular tool, you use it if you have in your, how many of you have this system in your home? Desktop. All of you having? All of you having your desktop in your home?
Yes, sir.
So I have posted this particular link in your chat box. I will once again post it. So this is a simple program which you need to do. Okay. So take this particular link once again, run it. So it will be displayed the screen like this. So this is the browser-based software which you are going to have. Okay. So once you have this one, you just it's already predefined code is there. Just find the code. Okay. So just what I need to do is first I need to have the move operation. So wherever the instructions are there, I'm going to move the contents. So move. I'm moving the data of R0 to #10. Okay. So that is I'm moving the data 10 to R0. Next, I'm going to move the data of 20 to R1. Next, I'm going to multiply the contents of R1, and I'm going to store the result in. I'm going to store the result in R2. So you can see it here in this particular in the browser-based IDE which you are going to have. So you are not able to include area directive. So that area directive and entry point and then your start, you have to use it only in your keel compiler. Okay. So here in this particular editor, it is only browser based. So it is only having the limited functionality. Okay. It will be having only the limited functionality. So here you are not supposed to have the endpoint also, and you are not going to have the start also here. Label won't be there, and area directive won't be there. So it won't have some values up, and it's going to have the address where that particular data has to be stored, retrieved. Okay. So now once you have typed this particular program, just run it. So when you are running it, you can see it here. What is the content of or not? I'm moving the content of or not. Is 10 to hexadecimal value, it will be A. The contents of R not, it will be A. All of you can see it.
No, sir.
All of you can see this one.
Yes, sir.
How many you can't see this particular window tool?
Again, it's lagging, sir.
Okay. Maybe you are which one you are using the internet? Wi-Fi or your phone-based internet you are using?
Mobile network, sir.
Wi-Fi.
Wi-Fi, if Wi-Fi, it won't lag, right? I think. So just look into here. Details of screen is visible now.
Yes, sir.
Okay. So now if you see the script, the screen is visible. You can see it here. The register value is there, right? So at the right side part of the right side of the screen, you can see it here. The register value is there. So I'm moving 10 to R0. So if you have this lap desktop, you just whatever the link I have posted in your chat box, you just click on that one. It will open the page. Okay, it will open the page. So all of you open that particular page. This is a browser based. Since it is a browser based, I think you can use it in your mobile device also. So now here you can see it here. I'm moving in 10 to R0. So the hexadecimal value of 10 is A. You can see it here. R0 is having A. So now I am moving. The second instruction is I am moving the instruction 20 to R1. So the hexadecimal value of 20 is what? 14. The hexadecimal value of 20 is nothing but 14. You can see that 14 is moved to the register R1. At the right side, you can see. At the right side, you
So
can
the
see it here.
register values are being displayed.
Yes, ma'am. Yes, ma'am.
The register's values are still 0 only, sir.
No, it is updated, right?
No, sir.
No, sir.
No, in my screen, it's updated. You can see it here. 1 minute. One more time I will run. So can you able to see the screen now? Able to see it?
Sir, the screen is visible, sir, but the register values is not updated.
Now I am registered. I have resetted now. Don't worry about that one. Are you able to see it? I have refreshed that one again.
Yeah, yes. Yes.
Okay. So now I'm going to modify the code here now. Can you able to see the modification what I am doing now? Can you able to see?
No, sir. No, sir.
So can you able to see now? Can you able to see? Students? Can you able to see the screen?
Yes, sir.
I have reshared that one again. So I'm started modifying now. Can you able to see the modification what I'm doing? Are you seeing that one?
Yes, sir. You're writing the code, no, sir?
Yeah, move I have written now. Move.
Yes, sir. It's visible.
Are you able to see? Move or not, comma. I'm moving the data 10. That is the decimal value 10 to or not now. Okay, it's visible, right?
Yes, sir.
Now, next after that particular instruction, I'm going to move R1, comma, hash 20. I moved the data 20 to R1, right? Can you able to see that one now?
Yes, sir.
Now, I am going to multiply the contents of R0 and R1. I am going to multiply the contents of R0 and R1, and whatever the result it is going to be obtained, that will be stored in register R2. Okay, can you able to see that part of the code now? So now
Yes, sir.
this part is infinite loop, which has been running because I have to stop one part of the code there itself. This is infinite loop, as we have discussed in the previous class. Now, once it is done, this particular type of browser-based uh, assembler, in the browser-based assembler, it is having the limited features. Okay, the complete features which is there in your Keel software, it won't be there here. Okay, so if you have the Keel assembler that I have been shared in the drive, I think, how many of you have downloaded? How many of you have downloaded that drive, the Keel software? Anyone? Is anyone is using Keel? I have shared that one. Even I will share the same link today also. You just go there, do that particular link and download the Keel software. Those who are having the desktop systems in your home, download that particular software and you start installing and you read it and you configure it. So your Keel software is an open source free version. You can download that particular Keel from your website also. That's not an issue. Okay. So now once you are drive like this, just type run. So you're going to have option of open, run, 250 step reset is there. So you can see at the right hand side, all the contents of the register value is 0. Once you type run, so if you run, the values of the register values change here. Can you able to see that one now? Can you able to see the contents of the register value is changed? Students? Students, can you able to see the contents of the register which has been changed?
No, sir.
Or you type it by yourself, you come to know. Okay, you type it by yourself, you will come to know, I think. So you can see it here. I'm posting that output in your group, class group. You can see there, the contents of the registers is changed. So in the WhatsApp post I have posted, you can see there. Why it is not able to see now? Registers value, which is changed.
So now the screen is not visible, sir.
Screen itself is not visible.
Sir, screen is visible, sir.
Ah.
But value is
Still it's not
Everything is
displayed.
zero.
Everything is zero only.
Yes, sir.
Okay, I will try another browser. Let us see. Or otherwise, you type the code there. Okay, can you it visible now? This particular part. I'm using the different browser now. Then it's visible now. Friends, hello. Whether it's visible now. Dear students, are you there?
no, sir.
This particular screen is also not visible.
No, sir.
So whether it's now it's visible. Whether it's visible now.
No, sir.
Students, whether it's visible
No, sir.
still.
No, sir.
Why? Open share key. R1, comma dash 20 multiply R2 comma R1 comma R0. So can you able to see all the changes made? Students? Hello? Are you able to see all the changes have been made in the code?
Yes, sir.
Now once you type the program, you just run it. Run. So when you run that one, you can see at the right side of the code. Can you see the changes in the register?
Yes, sir.
Now it's seeing, right? Now you can see it here, the contents of the register value or not. So the contents of the register value or not is what? 10 have been sent. So the hexadecimal value of 10 is A. The hexadecimal value decimal of 10 is A, what has been stored. Next I am moving 20 to R1. That is nothing but hexadecimal value of 20, which is 14. That will be moved to R1. So next it is going to multiply 10 by 20. So what's the value you are going to get? 10 by 20. 10 by 20 is 200. So you convert that one to hexadecimal value. So how much you are going to get? If you convert hexadecimal value 200, you can see if we do it for 200 divided by 16, it will be 16 on the 16, 16 4 the 40, 16 2, that is 8. So 12 and 8. So the value of 12 in hexadecimal is C and C8 you are going to get. So that is what the value you are going to get it here. C8. You can see it in the register R2, the register which you are getting. Can you try it in your system now? Can you try it in your system now? You try in your system, and once you get the answer, take the snapshot and send it to my official email ID, which I am going to post it now. suresh.p_csc@. So all of you run that particular part of the code in your browser. Use the browser, Mozilla web browser. So you click this particular link, you paste this particular link in the web browser, type in this particular code, and you run it. So at the register value, you can see the changes, what has been happened. So once you have done with this one, you just post that one to my email ID. Take a screenshot and post it to my number. Post it to my personal number. Email, official email ID. Anybody having any doubt? Anybody having any doubt? You can take this, use it as a reference for your class, and you run it. Run the code and get back the whatever the snapshot you are going to get. Just you post it on my email. So you do it at the earliest. I will give 10 minutes. You just run this particular part of the code in your system. Take the screenshot and just that particular image you send it to my email ID, which has been provided in the chat box. In the chat box, I have provided my email ID. To that particular email ID, you run the code and you take the snapshot and you submit it. So within 10 minutes, you have to send that one. So running